How's it going, folks? Thanks for coming back. So on this episode, we're going to be working on the control box and the control box wiring. And I'm going to show you how it goes together, and you'll see why I laid it out the way I did. It flows really well. It all works together really well. This episode is going to be just a little bit longer than some of the other ones because there's going to be a lot of wiring that we're going to be doing, but I'm pretty sure I laid it out to be really simple and easy to follow for everybody. And if you have any questions or comments, just like any other time, please leave those below. Also, if you can, even if it's just $1, $5, whatever you can, I got a link in the bottom here. I'm going to be doing a fundraiser for getting a GoPro. That way I can do probably a head cam where I can get more close up of the little detailed stuff that I usually work on with you guys and maybe get you a better angle to see stuff. So if you can help out at all, that'd be great. If not, no big deal. I just hope that you're enjoying these videos and that it's helpful. Let's get started on this control box. Alright guys, we're going to go over the control box and all the stuff that you're going to need for this episode and this stage of your build. Make sure you have all of your instructions, your stepper instructions here, your Mach 3 instructions, your wiring schematic. This is what we're going to be working off of for the majority of this episode. It's really important. There's your Mach 3 info. These are all your supplied cables. Make sure everything's labeled. Make sure the labels are stuck there really well. If not, relabel them. Your emergency stop button. That'll be on your lid. Your spindle wiring. Some scrap wire. It's always good to have extra. These are your stepper drivers. Mach 3 controller stand. Power inverter. Some more of your supplied wire. Heat shrink. Good stuff to have around. Your Mach 3 controller. These things are awesome. I don't know if you ever used them or not, but whenever you need to butt connect wires, it's a low temperature solder in the middle and waterproofing sealer on the outside of this. These are really great. This is just a different gauge one. And a Zippo lighter. I find that to be the easiest type of lighter to use when you're working with electrical. And your control box. Liquid electrical tape. This stuff is awesome to have around. Sharp razor blades. Wire cutter. Wire stripper. Helping hands for soldering. A good solder iron. A unit like this is great because it has a soldering iron and a hot air gun, and it's all controllable. You can control the temperature of the hot air as well as the force of the hot air. It's good for your heat shrink. and drying things. Soldering iron, the adjustable temperature. Make sure you have plenty of soldering wire. If you read the side here, it's pulling 20 amps. And when you're thinking about this, this machine is going to be running for a long time, sometimes unattended, because it's going to take 3, 4, 5, 6 hours to complete a project. So you're talking about this unit pulling 20 amps for a long amount of time, possibly unattended. I cannot express how important it is to make sure when you're choosing your power cable for this thing that you make sure that it is rated to be pulling 20 amps the entire time that it's going to be operational. 10 gauge is really the only gauge that you should be using for this to handle that 20 amps and not overheating and possibly becoming a fire hazard, burning up while you're not in your shop or you're not in your room that you have set up for all this. You don't want to be sitting there putting a project down overnight to be running and this get too hot and start a fire. So one of the easiest ways to do this for us here in the States is to go to Harbor Freight. There's a 25-foot long 10 gauge extension cord that's I believe it's $39, and then if you always can use a 20% off coupon and you just use that, and that'll give you everything that you need as far as safety wise. It'll be able to hold the 20 amp current no problem, and you'll have leftovers. Don't throw away your leftovers, because sometime, somewhere in the future, this will come in handy. Just like if I had a 10 gauge extension cord that messed up 10 years ago, if it was still sitting on the shelf, I'd be using that right now. So make sure that you pay attention to the amps that you're going to be pulling, and making sure that you don't ever underestimate what power can do and the fires that it can cause and the danger that it can pose. So this is an area not to skimp in. Right here, guys, we're gonna mount the power inverter in the control box. All the holes and everything should line up perfectly if you are using the control box that I designed. Depending on your printer or whatever settings you do, if you print this yourself, or maybe some of your equipment that you get with your kit, there might be some slight variations, but it should be easily fixable with a little bit of a drill bit. It shouldn't be too far off. You should be good to go. Everything should be pretty darn close, especially if you get the same kit. And for right now, we're just going to be mounting this power box in here, and the rest is going to go in one at a time as we move along in this process.
Noches nos juntemos todos los amigos.
3 side, your red and green wires will be together, and on the stepper driver side, your red wire will go on the first port there, and the green wire will go into the third port. So you will end up with red, blue, green, and yellow on the stepper driver side. On the Mach 3 side, you'll have the red and green together, the blue, and then the yellow. You're providing power to 2 different locations on the stepper driver from the one port from the Mach 3 controller. The easiest way to put these stepper drivers in is to put the bottom screw in first, keep it loose, set the foot in there, and then put the bolt through the top one, and it should sit perfectly. And don't forget, I made this to be expandable, so there's going to be one extra slot left open after you do this install. There's going to be that open space so that later on down the line, if you wanted to expand your machine, the space is already provided for another stepper motor driver. And it should be easiest to plug one in, wire it up, and you'll be all set to go. Take note right here that all of your home switches, all of the positives, go to a common port. So all 3 of your stop switch positive leads, solder them together, and they're going to go on the same port on the Mach 3 controller. This power box only pulls about 3 to 4 amps, so this 10 gauge wire is an overkill, but I already had it because I needed it for both the spindle and I needed a power cord anyways. So I'm just going to go ahead and use what I've already got, and it's going to have a little bit more robust wiring for this control box. Alright guys, right now we're going to attack the power cords going to our stepper drivers from the power inverter inside our control box. Just like before, like I was saying, it's always good to have some nice scrap wire around, and we're going to be using this for this 24 volt power supply to these stepper drivers. Pretty easy because of this length, so I'm just going to cut these into 4 even pieces and solder up, tin the wires, you know, solder them up. If you did not know, on your stepper drivers, all these plugs, they actually pop out. So you can pop them out and do individual work to each circuit, and be able to just plug them right back in. So it makes ease of access a lot better. So we're going to get wire in here, and then I'll get back to you. Guys, this was never intended to be any kind of a soldering class or anything, but my teenage child just asked me today about it, and I figured I could give a little quick demo about the way that I do it and how I was taught many years ago, working on hot rods and wiring up all the systems for that. Some of this thicker gauge wire is just easier. I just take this little thing, a pan of flux, and dip the wires into it. Probably don't need that much, but it's just easier and cleaner. Don't have a brush that collects dirt and whatever. You know, you just keep it like this. With copper wire, it goes really fast. It conducts the heat really quickly. So twist it up, get your flux on there. Make sure you don't get your face right up close to it, because the flux does spit a little bit. Some people put water on their sponge here, which is fine to do. You can do that if you want. I'll put some on there just for the sake of doing it. That's of course to clean your tip with that, and this copper wire here, flux impregnated, so it cleans the tip too. I don't know if you can see the difference, but it's got a little shiny tip to it. So things got to be clean in order to get things to solder correctly. So this is just simple, basic tinning wire, and the idea is that you're going to pull solder through all these wire fibers here. So it's going to be completely impregnated with this solder by the time you're done with it. You have to load your tip here with solder, and I like to put a bead right across the top. Now that's not in there, right? So Now solder is just like oil is for cooking. Oil conducts the heat from the pan to your food that you're cooking. The solder conducts the heat from the soldering iron into the material that you're soldering. So I got this solder right here in the tip, and you're gonna see once this gets up to temperature, you'll see all this solder right here. It just smooths out and it sucks into the wire itself. Just like that. Again here, this is a little thicker. When you go to the 22 gauge and stuff like that, which a lot of this kind of stuff is done in the electronic stuff, you don't have to do this ribbon. I mean, you don't have to do it at all, I guess, but this is just the way that I've done it for, I don't know, 20 years. So it's the way I'll probably stay doing it. Remember that oil conducts the heat, the solder conducts the heat, and then you'll see it just envelop into the wire. Now this copper, it really conducts that heat quick. Some other wires, like the tin coated wire and stuff, you can still solder it, no problem, but it takes just a tad bit longer for the heat to completely go into the wire. The solder is going to go to where the heat is and the flux. The flux is your bonding. You can get like rosin core solder that has the flux in the middle of, like, it's hollow in here. Not on this one, but it's hollow and the flux is actually inside. But once you're doing a lot of wiring, you'll just be able to do this no problem. Just dipping your pieces of wire into the flux and using regular 60-40 solder is pretty good for this. The only time you really change it up, the type of solder you use, is whenever you're going to like copper pipes that are for household. You don't want that lead in the water that you're going to be drinking. So that's it. That's basically it. It's real simple. It cools down really quick too, but right away this whole thing will be hot, so don't mess with it right away. The soldering iron, I go with 400 degrees, but you can increase it for thicker gauge wire and decrease it for smaller gauge wire. But that's it for that. Okay guys, we're gonna hook this up. So when your switches are laying like this, your positive is on your left, your negative is on your right. So take your wire here, and you always leave extra on your wire, like 10 a good amount, and then when it comes to the time that you're going to install it or going to be needing to, you know, hook it up to your switch, then trim it. It's always good to have more than you need than to get to this point and you don't have enough to do what you need to do. Just put it in here. If I can do this with this awkward camera in the way. Snug it up, make sure it's in there. Snug, it's good, it's in there. Alright, so now we got all 4 of these. Now I'm going to show you how we're going to hook it up inside the control box. So right here, here's you have 3 positives and 3 negatives for your power inverter here. They're all outputting 24 volts. And right here on the first one on the right hand side of both the negative and the positive, this is your power for your controller. It's wired to here. So we're going to use these 2 negatives, these 2 positives for our stepper driver plugs that we just made. So to do this, we're going to plug it into the stepper driver. If you've got smaller hands, or you got a wife that can do this, makes things easier. Mine's in bed. Kids are in bed. So, big fat fingers it is. Plug that in. Try to keep it somewhat neat. Alright, so that's the first one. And we're gonna go with this negative. First negative on the left side, and the same with that one. Don't tighten it down yet, because you still have one more here you got to do of this series of 2. Let's wire this in here. Okay, we're going to this next one. Plug it in, and right there. So do one on the left and one on the right. And hold these down and tighten it up. Now, if you have any wires here, whether it's your other positive stuff or anything here that, you know, any extra wire that's sticking out that's a little unsafe, just like on some of the other stuff, just put a little dab of the liquid electrical tape and you should be okay. Okay, that's it. Just do the same thing for the other 2 with these 2 ports, and you'll be good to go. Alright guys, that was it for this one. Went pretty well, I thought. Hopefully I laid it out as simple as possible and that there's no confusion. I like the liquid electrical tape. I think that's really important to be using that to make sure that some of the wires that are really close together, that they don't accidentally come in contact sometime while you're operating a machine. It's just better to be safe than sorry. If there's any questions, please don't hesitate, just ask them. Also, again, if you don't mind contributing to that GoPro fund, I'd much appreciate it. And of course, if you can subscribe and like this video and hit that bell button so that you're updated every single time I put a new episode on. All right guys, thank you. See you next time.